Welcome back, folks. We're going to wrap up our lesson on similarity in right triangles. I keep changing the rules as I'm going. So before we have talked about, I said, well, we're going to be done in 2 videos. This is now the 3rd. We talked about identifying similar triangles. I thought I was going to get into something I didn't get into. Then we talked about finding the geometric mean, and I realized some people might be scared from solving for x squareds, so I had to slow down on that. And then we ended up using the similarity corollaries, which is understanding geometric mean. Finally, we're getting into finding a distance. So this should be the last installment, and I'll try to make it quick because we do have to do some more trips down memory lane. First, a refresher of our memory. We talked about the notes of geometric means. We understood that geometric means were all about the altitudes of the large triangle. We could separate geometric means using our 3 triangles, or we could remember the shortcut. The geometric means have to do with the other sides that the altitudes can touch. Okay, so the other sides that the altitudes can touch. And then we can set up our little geometric mean equation. We had some practice on that. So that leads us to our last example. And then I'm going to take a pause through the example to go over factoring, but we'll get there when we get there. Okay, so we will get into factoring in a second, but first, an example. So here we're doing robotics, right? We're preparing for a robotics competition using this setup here. Points A, B, and C are located such that AB is 20 inches. AB is perpendicular to BC, so we have a right triangle. Point D is on AC, so that BD and AC are perpendicular, and DC is 9. Okay, so we have this whole setup, like with all the words here, basically explain the picture you're looking at. The question is, how far does a robot have to move to go from point A to point D? The question is, what is that value of X? And we can also, by the way, understand the value of BD here. Okay, so we will get there in a second. But how's that going to work? Okay, well, first of all, what are we given? We're looking at finding the value of x, this distance here. Now that is not a geometric mean. That's not an altitude. But the question is it related to an altitude? And hopefully you see that yes, it is. The distance x is related to the altitude 20. So if you spin the triangle so that you can see 20 as an altitude, if you can see 20 as an altitude, 20 has a relationship with the other 2 sides it touches. Remember, 20 is the geometric mean. So 20 is related to this side and this side. Okay, so 20 is related to x and all the way across from A to C. But the question is, Mr. Katz, what is the distance from A to C? Okay, so the distance from A to C is the value x plus 9 more. So that's a challenging step to take right there, understanding that the distance from A to D is x and the distance from A to C is 9. So from D to C is 9, so all the way to AC is x and 9 more. Okay, so back to the altitude. 20, the geometric mean, is related to both x and x plus 9. So there we have our geometric mean equation. Okay, so how does that work? 20 is the geometric mean. So we put the 20 where it belongs. 20 is the geometric mean. So what are the other 2 sides it can touch? It can touch x and it can touch x plus 9. So we have x and x plus 9. All right, so we have our setup now. So the only other question is, how do we solve that equation? Well, let's cross multiply. We're going to find cross products. So we have x times x plus 9. So we have x times x plus 9 is equal to 20 times 20. Product of the means is equal to the product of the means. Now we can use the distributive property. X squared plus 9x equals 400. And so that's about where we are. How in the world will that work? Okay. If you don't quite remember solving quadratics, let's get into a history lesson. So here we're going to pause. Then we're going to go back into a history lesson. Okay? So I have a few examples of factoring, but then you might be thinking, well, Mr. Katz, what does that have to do with anything? So let's factor this first, and then we'll get into it. Now, there's a whole other video on factoring polynomials, but let's do the down and dirty. if x, the coefficient for x is 1, we can tell right away that our two factors are going to have x and x. The only question is, what two numbers multiply, in this case to negative 10, but then add to give us negative 3? Okay, so this is the question. What two numbers multiply to negative 10, but add to negative 3? So you run through your factors, and hopefully you realize that the answer to that question would be negative 5 and positive 2. Okay, so hopefully you realize the answer to your own question will be negative 5 and positive 2. So how do we factor this trinomial? We have our x's set up here, the two numbers that multiply negative 10 but add negative 3, boom, bam. That's one of many ways. Go watch the previous video. Same thing with this example as well. Okay, so we have x squared, 1 is our lead coefficient, so we can set it up right away. And again, the question is, what two numbers multiply to negative 18 but add to positive 7? Okay, so you go through your factors. 6 and 3 ain't going to cut it. 1 and 18 ain't going to cut it, but 9 and 2 certainly cuts it. So 9 and 2 would be the answer, but a positive 9 and a negative 2. Okay, a positive 9 and a negative 2 fit the bill for that. Okay? Okay. But now what? There's another thing that goes on, the zero product property. So let's just say, for example, if we had two factors being multiplied and their product was 0, how could we solve that? Well, what does this mean? This means either this factor, x minus 5, is 0, because if this was 0, the whole thing would be 0, winning. Or the other factor is 0, or x plus 2 is 0. Because if x plus 2 was 0, this would be x minus 5 times 0, which is 0. So we have those two possibilities. It's called the zero product property. It's all in the previous video. I'm just dusting off memories. So either x could equal positive 5 when I add 5 to both sides, or x could equal negative 2 when I subtract 2 from both sides. Okay, so I have to remember how that works. Okay? So we have to remember this. For more information on that, you have to watch the previous video on solving quadratics and factoring and all that stuff. Okay? Okay. So that's our trip down memory lane. Let's unpause and bring us back to where we were. Okay, so we were here, correct? Correct. We had x squared plus 9x equals 40. Remember? Because 20 was the geometric mean. We had to cross products, property, and all that stuff. Now we have this. So how do we solve this? Well, the first thing we have to do is set this equal to 0. If we set it equal to 0, we would have a quadratic equation equal to 0, and that's what we want. So how do we do that? We subtract 400 on both sides. So we have x squared plus 9x minus 400 equals 0. Now what? Now what do we do? Well, now we factor. If we factor this, we can use the zero product property. So how in the world do we factor this? Well, our lead coefficient is 1. Okay, so we have x and an x. The question is, what two numbers multiply to negative 400 but add to positive 9? Multiply to negative 400 but add to positive 9. So that is the key question. And so you go through your factors of 400. Right? Could be 4 and 100, that ain't going to work. Could be 20 and 20, but that's not going to work. And you keep running through your factors until you realize you have a relationship between 25s. Okay, how many quarters make up $4? 25 cents. So 4 quarters of a dollar, 16, right? So 25 and 16. 25 and 16. Any guesses what 25 minus 16 would be? 9. So the answer to our question here would be a positive 25 and a negative 16. So we have factored our large polynomial there, but remember the zero product property. That means either x plus 25 could equal 0, or x minus 16 could equal 0. Okay, so either x plus 25 is 0 or x minus 16 is 0. So we run through our possibilities. If we solve for x in here, x could be negative 25. If we solve for x here, x could be 16. So clearly we have two answers, right? Negative 25 and 16. clearly, hang on now. Remember what we were looking for. We're looking for x. Is this possibly a negative number? Absolutely not. It is impossible for x to be a negative number. So we must therefore conclude that x equals negative 25 is what's called extraneous. So the only solution for x is 16. So how far does the robot travel from A to D? 16 units. 16 units. Okay, so that's how that would work. Now, for another example, what if we wanted to find this value here, this value y here, from B to D? We could even find the distance from B to C. Okay, so we can find all of these distances, but let's find y. Okay, y is an altitude, so y is a geometric mean. Okay, so we set it up such that y is the geometric mean. And y can touch either value. Y can touch 9 and y can touch 16. Okay, so now we can solve for y quite easily. So check this out. I'll give you a little numbers trick. That means y squared equals 9 times 16. I am not going to multiply that out, and I'll show you why. In order to solve this equation, we would take the square root of both sides, right? So y is equal to the square root of 9 times 16. But guess what the square root of 9 is? 3. Guess what the square root of 16 is? 4. Y is equal to 12. I hope you enjoyed that trick. That was awesome. If that was too fast, pause and rewind. So now we can find out the distance is 12. And we can do the exact same thing. Okay? So we can find the, maybe we want to find z, the distance from B to C. We'll call that z. Okay, so we can even do this again. Z is an altitude. Z is a geometric mean. So we have our z's set up. We're going to have our z set up. Okay. Z is our geometric mean, but what is it related to? It's related to 9 and 25. 9 and 25. Okay, so I can now solve for z. And I'll do it the same way to the other one. So z squared is equal to 9 times 25. So z is equal to the square root of 9 times 25. The square root of 9 is 3. The square root of 25 is 5. So therefore, z is equal to 3 times 5, or 15. Okay, so we can find that as well. 15 units, 12 units, 16 units. These are all of the missing values, and we can use that, use geometric mean with doing that. Okay. All right, so I'm going to wrap this lesson up with a quick quiz. All right, so a quick quiz. So we'll do these as fast as we can. What similarity statement can you write relating the three triangles in the diagram? Okay, so the three triangles in the diagram. The first answer is YHB. So YHB, that means the right angle is H. Is that similar? Well, first of all, I think congruent. YHB, how about YDH? YDH, that might work. Because D is the 90-degree angle, and HDB. HDB, that might work because D is the 90-degree angle. How about YHD? YHD, D is the 90-degree angle. HYB, HYB, nope, H is 90-degree angle, so it's not that. Has to be B. B is our correct answer. So see how quickly we can do that. By the way, I haven't looked at these too much in advance. I'm just solving this as we go. What are the values of x and y? So more geometric mean statements here. Y is a geometric mean, correct? Correct. So we can set up our equation. And y is related to 36 and 56. Okay, so y is related to 36 and 56. So that means y squared is equal to 36 times 56. So y is equal to the square root of 36 times 56, or 6 root 56. But 56 is, let's see, 8 and 7. Okay, so that's, what is that? 8 and 7 is 2 root 2, so 2 root 14, 12 root 14. There's our y. Y is equal to 12 root 14. Done. Done. So there, I solved that one. So you only need to do one of them, right? But a neat trick without using a calculator if you understand numbers. So that's how that works. Hopefully you enjoyed or at least learned some stuff about similarity and right triangles. This stuff does get tricky. Fun times, though. Take care. We're going to finish off this whole unit with proportions in triangles. Later.